Welcome to Unit 1, Lesson Topic 3, Part 3. This comes from Lesson 2-3 from our textbook, Multiplying and Dividing Rational Numbers. That's Pearson, copyright 2009, Algebra 1. Our objectives today are, I will be able to multiply rational numbers, and I will be able to divide rational numbers. We could add a third objective to that. I will be able to solve problems by multiplying and dividing rational numbers. In our previous lessons, we looked at the rules for adding and subtracting rational numbers. Now, we're going to look at the rules for multiplying and dividing. So let's get this math party started. When multiplying rational numbers, we have to be worried about some basic properties that you probably already know, but it's good to review them. Our first property here is the identity property of multiplication. For every real number n, 1 times n is equal to n, and n times 1 is equal to n. The actual identity in this case is the number 1. When you multiply a number by 1, it doesn't change the value. So here we have a couple numerical examples. 1 times -5 is equal to -5, and -5 times 1 is equal to -5. Again, when you multiply by 1, it doesn't change the value. The second property is the multiplication property of 0. Mathematically stated, for every real number n, n times 0 is equal to 0, and 0 times n is equal to 0. In other words, any number times 0 is always equal to 0. Here we have some numerical examples. 35 times 0 is equal to 0, and 0 times 35 is equal to 0. We could use any number multiplied by 0. You always get 0. Lastly, here we have the multiplication property of -1. Mathematically stated, it reads, for every real number n, -1 times n is equal to the opposite of n, and n times -1 is equal to the opposite of n. Basically, multiplying by -1 changes the sign of the number, but it's not its absolute value. When you multiply by a -1, you change the sign of the number. We have two more rules or properties that we need to talk about before we actually do examples with multiplying rational numbers. The first rule is multiplying numbers with the same sign. The product of two positive numbers or two negative numbers is positive. So if they have the same sign, the answer is going to be positive. So if they have the same sign, the answer is going to be positive. Numerically speaking, same sign, the answer is going to be positive. Numerically speaking, 5 times 2 is equal to 10. More specifically, positive 5 times positive 2 is equal to 10. We just don't need to put the positive sign or say it. In this case, -5 times -2 is equal to 10. That's a positive 10. Notice when they're the same sign, the answer is positive. The second rule we need to concern ourselves with is when we are multiplying opposite sign or different sign numbers, so multiplying numbers with different signs. The product of a positive and a negative number, or a negative number and a positive number, is negative. So when you're multiplying opposite sign numbers, you're going to be getting a negative answer. So when you have different signs, the answer is going to be negative. Numerically, 3 times -6 is equal to -18. -3 times 6 is equal to -18. It doesn't matter the order. If one's negative and one's positive and you're multiplying, the answer is always going to be negative. We're getting right into multiplying numbers here in example 1t, where we're told multiplying numbers. So we have to simplify this by multiplying. Now, the rule that applies here is the same sign numbers. -3 and -11, that would be the same sign rule, which states that if they have the same sign, the answer is going to be positive. So all we have to do is multiply 3 and 11. 3 times 11 is, of course, 33, and the answer to that is positive because they have the same sign. In Part B, we actually have some rational numbers to multiply. An integer times a rational number, so we have to go -6 times 3/4. And this is doing it by hand. That's the goal of this first unit, is to review how to do things by hand. So a negative times a positive, well, that's always equal to a negative. That's the different signs rule. The different sign rule, where it states if you have a negative and a positive and you're multiplying, the product would be positive. Now, if we think of 6 over 1, and we can cross cancel here. 6 and 4 are both divisible by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. So then when we multiply, 3 times 3 is 9, and 1 times 2 is 2. Our fraction's already reduced, and we have a final answer of -9/2. So this part B, not only did it review how to multiply different sign numbers, but it also reviewed how to multiply an integer by a fraction. We're continuing our work with multiplying rational numbers here in example 2t, where we're evaluating expressions. When we see that word evaluate expressions, that usually means we're going to have to substitute values in. And our problem reads evaluate 5rs for r is equal to -18 and s is equal to -5. And in case you're unaware, this 5rs, we could also read that as 5 times r times s. That means multiplication. So we're going to have to substitute in -18 for r and -5 for s. So that'll be 5 times -18 times -5. We substitute in there -18 in for r and -5 in for s. Now we have to multiply. 5 times a -18. Well, if you can't do that in your head, that's okay. You go 5 times 18. 5 times 8 is 40, carry the 4. 5 times 1 is 5, plus 4 is 9. That'd give us 90. And since we multiplied a positive times a negative, that would give us a negative. Then we have to take 90 multiplied by 5. -90 times a -5, actually. And since we have a negative times a negative, our answer is going to be positive. And 90 times 5, the way I line this up is I just put the 0 over here and I drop it down to my answer. And I do 5 times 9 is 45, and my final answer there would be 450. Now there's a really cool thing if you have an even number of negative signs. If you have an even number of negative signs, the answer is going to be positive. And if you have an odd number of negative signs in your expression, the answer is going to be negative. So that's something neat to remember here when you're multiplying multiple numbers and you have lots of signs. If you just count up the signs, in this case we have 1, 2 signs, and 2 is even, so our answer is positive. That's kind of a quick way to find your signs. Example 3t is going to require us to multiply rational numbers. Use the expression -5.5 times a over 1,000 to calculate the change in temperature for an increase in altitude of 7,200 feet. In this problem, it tells us right here that the altitude is represented by the variable a, and that 7,200 is an increase in altitude of 7,200 feet. So what we're going to have to do is take the given expression, -5.5 times a over 1,000. Now I know that looks like a 9, but it's a lowercase a. And we're going to have to substitute in 7,200 for that a. So doing that, our expression will look like -5.5 times 7,200 over 1,000. And then we're going to have to simplify this. And to simplify this, if we take 7,200 and divide it by 1,000, that's going to give us 7.2. We need to multiply that by -5.5. Notice I switched where the parentheses are at, and that's okay. It doesn't change what we have to do. So we have to do 7.2 times 5.5. Of course, we know our answer is going to be negative because we have a positive by times a negative, so the answer is going to be negative. 5 times 2 is 10, carry the 1. 5 times 7 is 35, plus 1 is 36. I hold a place value here. 5 times 2 is 10, carry a 1. 5 times 7 is 35, plus 1 is 36. Add those two together. 0, 6, 3 and 6 is 9, and 3 plus nothing is 3. And since these two numbers combined have 2 decimal places, starting at the right and moving to the left, our answer should also have 2 decimal places. So here we have 39.6. 6, 39.6 degrees, because this is a temperature. It's going to drop almost 40 degrees. When multiplying rational numbers, it's going to be important to know the difference between these two expressions right here, negative 3 to the fourth and the quantity negative 3 to the fourth. In reality, this first expression, when it's written without parentheses, this is said with the word opposite. We should read this as the opposite of 3 to the fourth power. Using the concept of exponents and meaning repeated multiplication, we could and should write this as, if we were to expand it, the opposite of 3 times 3 times 3 times 3. That would be the same as this expression here. Now, this expression, when we have it with parentheses, negative 3 in parentheses to the fourth power, that means we need to multiply negative 3 by itself 4 times. The negatives go with the 3 each time. Here, since there's no parentheses, all we're doing is raising 3 to the fourth power, and then we're going to take the opposite of that. So in this case, 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 is 81. This would go ahead and give us a negative 81. And this, negative 3 times negative 3, is positive 9. Negative 3 times negative 3 is positive 9, and 9 times 9 is 81. This evaluates to give us a positive 81. Now, when you write this and think this, that's kind of okay, but if using a calculator, you have to put the negative number in parentheses when raising it to a power. You have to put, especially when using a calculator, a negative number in parentheses when raising it to a power. The reason example 4 is in the multiplying rational number section is because we have to simplify exponential expressions, and anything with an exponent means repeated multiplication, so that's why it's included in the multiplying rational number section. As you saw on the previous slide, to use the order of operations here, we have to do the exponent first. And we're going to take the opposite of 0.2 to the fourth. So writing that out as I did in the last slide, that would be the opposite of 0.2 times 0.2 times 0.2 times 0.2. That's writing 0.2 to the fourth out, and we have to take the opposite of that. Well, 0.2 times 0.2 is 0.04. We have to multiply that by 0.2 times 0.2, and again, that gives me 0.04. And when I finally multiply 0.04 times 0.04, that gives 0.0016. Now, of course, that's positive, but because we have to take the opposite of that, the final answer here is negative 0.0016. Because of the inherent difference, because this has parentheses and example A does not, we would calculate this differently. That's going to be negative 0.2 times negative 0.2 times negative 0.2 times negative 0.2. Negative 0.2 to the fourth, not the opposite of 0.2 like example A. Now when I multiply negative 0.2 times negative 0.2, that gives me 0.04. This negative 0.2 times this negative 0.2 gives me 0.04. And when I finally multiply those two together, it gives me positive 0.0016. So because, again, this does not have parentheses and this does, that gives us a different sign in our final answer. Example 5t, dividing real numbers. We're told to simplify each expression. Each of these expressions really boils down to a basic or very simple division problem, but what we need to concern ourselves with is the sign of the answer. In part A, we have 70 divided by negative 5. Well, concerning ourselves with that sign, a positive divided by a negative is always a negative, and we have to do 70 divided by 5, which is a pretty simple calculation. So we do 5 on the outside, 70 on the inside, and we divide. 5 goes into 70 one time. 1 times 5 is 5. Subtract, we get 2 left over. We bring down this 0. 5 goes into 24 times. So 5 divides into 70 14 times. So our final answer here is negative 14. In part B, it's a basic multiplication fact. 54 divided by 9 is 6. And a negative divided by a negative is always a positive. So our solution here is a positive 6. The key takeaway when dividing rational numbers or sign numbers is that if you have same sign, the answer is positive, and you're dividing opposite sign numbers, the sign is negative. In example 6t, we're going to be multiplying and dividing to evaluate this expression. The directions tell us to evaluate the opposite of x divided by y minus 4 times z squared. Now, we have to substitute and get our signs correct to get the final answer correct. We're told that x is equal to 4, we're told y is equal to -2, and we're told z is equal to a -4. So we have to substitute or replace those numbers for the variables in the expression. So starting off with the expression, it's the opposite of x divided by y. So in this case, that would be 4 divided by a -2. Now notice we have a double negative here. The opposite of 4 divided by -2. So we'll deal with that in a moment. Minus 4 times z squared. Now z is a -4, so remember you need to put that -4 inside a set of parentheses to get the correct sign. Now let's go ahead and follow our order of operations. We can do this division at the same time we do this exponent because exponents are really just multiplication. So 4 divided by a -2 is -2, and outside that -2 we should bring down that opposite or that negative sign. Then minus 4 times -4 squared, and -4 times -4 will give us a 16. Continuing to simplify, the opposite of a -2 is a positive 2. -4 times 16 is -64. And then when we subtract here 2, take away 64, we would really, as we learned in a previous lesson, write this as 2 plus a -64. And 2 plus a -64 is -62. Remember, we have to subtract their absolute values and give the sign of the answer the same sign as whatever number has the greater absolute value. In this case, that would be -64. So our final answer is negative here, and a -62 to be exact. Here we have to talk about a property, the inverse property of multiplication. For every non-zero real number a, there is a multiplicative inverse 1 over a such that a times 1 over a is equal to 1. Basically, the multiplicative inverse is the reciprocal of a given number. In this case, we have 5 times 1/5 is equal to 1. Now remember, 5 times 1/5, if we think of 5 over 1 as a fraction, the 5's can either cross cancel or we can multiply that out. 5 times 1 is 5, and 1 times 5 is 5, to give us 5 over 5, which of course does reduce to 1. It also works with negative numbers. Negative numbers have multiplicative inverses. The multiplicative inverse or reciprocal of a non-zero number a over b is b over a. 0 does not have a reciprocal. So the words that we need to fill in here, the multiplicative inverse or reciprocal of a non-zero rational number a over b is b over a, and it tells us that 0 does not have a reciprocal because you can't divide by 0. And this was taken from our textbook, Prentice Hall Algebra 1, copyright 2009, on page 73. Before we move on and take a look at how to multiply or divide rational numbers, or fractions if you will, I want to review how to find the multiplicative inverse. We just defined the multiplicative inverse, and for part A we're given the fraction 2/3, and 2/3 multiplicative inverse is very simple. We just switch the numerator and the denominator. So the multiplicative inverse of 2/3 is going to be 3/2. For part B here, the multiplicative inverse of 4/3 simply is going to be 3/4. We invert it, we flip it, we turn it upside down to find the multiplicative inverse of a fraction. Now, in part C, we're given the whole number 4. Well, whole numbers are rational numbers, and remember, if we express that as 4 over 1, we can find the multiplicative inverse very easily, and that would be 1 over 4. Where some students get confused or concerned is when we're given a mixed number, as in part D where we have 2 and 1/4. A lot of students are just going to flip that 1/4, and that's incorrect. To find the multiplicative inverse of a mixed number, we first have to convert it to an improper fraction by going 4 times 2, which gives us 8, and 8 plus 1, which gives us 9. So 2 and 1/4 as a fraction is 9/4, and its multiplicative inverse would be 4/9. So remember, when working with whole numbers and mixed numbers, they do have multiplicative inverses, but we have to make them into fractions first. The reason I talked about multiplicative inverses is because to divide fractions, we actually need to multiply by the second fraction's multiplicative inverse. We really don't know how to divide fractions per se, but what we will do is we will multiply by its reciprocal to divide them out. So in this case, 2/3 divided by 4/7. To do this calculation, we're going to rewrite the problem as 2/3 times 7/4. Notice the two changes I made here. I changed the division to multiplication, and I changed the second number. I used its inverse or its reciprocal. Okay? To divide two fractions, we need to multiply by the second fraction's multiplicative inverse. So in this case, 2/3 divided by 4/7 becomes 2/3 times 7/4. Now in this case, what we can look to do is cross cancel or cross divide. 3 and 7, we can't divide anything into those, but in 2 and 4, if we divide them both by 2, they can cancel or divide each other out, and we can reduce before we multiply. 2 divided by 2 gives us 1, and 4 divided by 2 gives us 2. Now we multiply by multiplying the numerators, in this case 1 times 7 to give us 7, and 3 times 2 in the denominators to give us 6. So 2/3 divided by 4/7 ultimately becomes 7/6. The second problem is similar to the first problem, except it looks different. It's a compound fraction. It has one or more fractions inside of a fraction. And the way we deal with this is we just rewrite it like this kind of problem here. This means 2/3 divided by 4/5. So we write down exactly what I said. 2/3 divided by 4/5. Now we use the idea that dividing by 4/5 is the same as multiplying by 5/4. So we'll rewrite the problem as multiplication. It's going to become 2/3 times 5/4. Like we did in this example, let's look to cross cancel. 3 and 5 can't cross cancel, but 2 and 4 can. Again, if we take 2 divided by 2 and 4 divided by 4, those will cross cancel. 2 divided by 2 will leave us a 1, and 4 divided by 2 will leave us a 2. Now we multiply numerator to numerator. 1 times 5 is 5, and 3 times 2 is 6. So we have a final answer here of 5/6. Remember, dividing by a fraction, we need to multiply by its reciprocal. In example 7t, we're continuing our work with evaluating expressions. And it tells us to evaluate p divided by r for p is equal to 3/2 and r is equal to -3/4. So starting off with what we're given the expression p over r. We're told that p is 3/2 and r is -3/4. So what we have to do is substitute those numbers in. For p, we'll have 3/2 over -3/4. And as you can see here, we have one of those compound fractions. And as we just reviewed, to simplify this compound fraction or to the calculation here, we're going to go 3/2, we're going to rewrite it as 3/2 divided by a -3/4. To finish this calculation, we have to, instead of dividing by -3/4, we're going to rewrite that as 3/2 times a -4/3. We have to multiply by that number's reciprocal, or its multiplicative inverse. And now we try to cross cancel, which we can. 3 and 3 can cross cancel by a factor of 3. So dividing both of those by 3, 3 divided by 3 is 1, and 3 divided by 3 is 1. 2 and 4 cross cancel or divide. 2 divided by 2 and 4 divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So now we multiply what remains in the numerator. 1 times 2 is 2. And in the denominator, we have 1 times 1 to give us 2 over 1. Now, we have a positive times a negative, which always gives us a negative answer. And simplifying this a little bit further gives us a negative 2. So when starting with this expression, p divided by r, and p and r are both fractions, we had to use some basic math skills combined with our new knowledge of sign numbers to get our final answer.